Good morning, good afternoon, or good evening, depending on where you are in the world. Welcome to the Spring webinar program. Your host, as always, is myself, Peter Humphrey. We're joined today lucky enough to be joined today by the Spring team and also the Reactor team, as we are here to celebrate the reactive release of Spring Framework 5.0. So a few things before we get started. Just to let you know, you can use the question panel on your user interface to ask questions. We will be changing more of a panel format today, and you can enter in questions into the question channel, but we will try to address some of the questions that we feel relate to the individual conversations as we see during the webinar itself, not at the end. If we don't get to your question, we'll answer it and post it in an attachment which will be posted to the replay. The replay will be located at the exact same URL that you use to register. Lastly, we certainly encourage questions, and we'll have a quick poll at the very end of the presentation, so hang around, and we're likely to have a fun time talking together with you today. Juergen, let's talk a little bit about Spring Framework 5.0 and dive right into it. Why did we release this now?
All right. A welcome from my side. I've got the honor of kicking this off today. Spring Framework 5.0 is a really significant step for us. We really mean this bumping up of a version number right there in the front. If you remember the last time around, we had Spring Framework 4.0 introducing so many things that got further enriched and completed in 4.1, 4.2, 4.3. We really have a couple of years behind us with lots of feature introductions, a very up-to-date language support for Java 8, etc., etc. So why 5 now? Why are we bumping it, right? Well, it's a very significant step for us, for a start. We raised the source code level of the entire code base to Java 8. We raised the number of APIs, all the APIs that we have, to Java 8 level. So we can use Java 8 API types in our interface signatures. We can expose Java 8 API and language power to you in an even more comprehensive form than before. Before it was basically supported for your code in your applications, but the framework internally, of course, was JDK 6 based and could only conditionally support Java 8 constructed runtime. So to us, this is a complete revision of the entire framework code base on a Java 8 language and API level. And we proceed here along several themes. We have a functional API design theme. Of course, we have a reactive theme here, the integration with Project Reactor, the introduction of a fully reactive web framework that we call Spring WebFlux, next to Spring Servlet MVC, to Spring MVC on a servlet stack. So there are really many things that we take into account here in a complete revision of basically the entire set of APIs from the ground up, from the core container to the web frameworks and deep into the internals of the framework. Of course, this is a significant step for a start. We don't leave it at that, of course. We also look towards the upcoming generation of infrastructure. There's JDK 9 just released here. There's Java EE8 as a set of APIs, including Servlet 4.0, Beam Validation 2.0, the JSON Binding API, JPA 2.2, that we integrate with in a very, very timely fashion. Because if you check the calendar, JDK 9 just went GA basically a couple of days ago. The Java EE8 APIs went GA in the course of September. So we really have a very perfect timing here. We're able to support all those APIs, and in particular JDK 9 in its GA incarnation right from the start when we start the production line in Spring Framework 5.0 here. There's of course a lot more. There's a very central theme in terms of Kotlin. Kotlin as a very promising alternative JVM language. Along the lines of our focus on Groovy in recent years, we extend our reach here, not only to Groovy, but also to Kotlin. We're basically giving Kotlin the same first-class treatment, the same first-class love, even more first-class love, you could argue, from a core framework perspective, as with Groovy back in the Spring Framework Autodetecting days in particular. Kotlin really goes all the way through as well. We have Kotlin API extensions allowing for a very idiomatic Kotlin development experience against Spring Framework APIs, and from the bottom up, from the core container up to the web APIs, of course. For example, the WebFlux functional style. So it's the Java 8 language level. It's the Kotlin language philosophy that really has an impact here, was a very influencing factor here. And last but not least, we also reach out, of course, to our open source ecosystem out there. We are embracing JUnit 5, very recently released, also not even a month old in terms of its GA form. And we're also integrating with many other up-to-date versions of the libraries, for example, Jackson 2.9 and others that we have just recently had around us. The timing is perfect also for you to dive into this. There's, for example, Tomcat 9 just leaving its milestone phase and going into a stable phase right now. So there many things are coming together at this very time. Of course, our own project Reactor, which you're going to hear about more in just a minute. Project Reactor 3.1 recently went GA. We have RxJava 2.1 around us now. We are really tracking the ecosystem around us. And this also connects back to the initial question, why now? Because many threads of development, many efforts out there in the industry, in the ecosystem, are coming together now. They are really reaching a point of stability, of maturity that we haven't really had before. So waiting for RxJava 2 to materialize, reactive streams, the underlying API foundation, to stabilize, for Reactor 3.1, for the async rendering support in, for example, Jackson 2.9, in Thymeleaf. There are so many efforts out there in the open source ecosystem, all of which are coming together now from an infrastructure perspective. From an application perspective, of course, there are also many needs that are expressing themselves more clearly now. You may already have hit some of the barriers, of the limitations of traditional web architectures. We are really providing new ways of composing specific application architectures for your purposes, depending on the needs that you have, that you've already learned about, that you've already developed an understanding about. Our toolbox is very rich now, not only in the traditional space, but also in terms of reactive web architectures. So many things coming together at an almost ideal time. I'm personally very glad that we also have JDK 9 GA around now. A new revision of the JDK is always a source of inspiration and a source of first-class love for the Spring Framework team. All right. So this is basically Spring Framework 5.0. Many details, features in the details waiting to be discovered. So definitely check it out, and check it out in the details. For today's purposes, we're going to focus on our reactive toolbox, on what we allow you to do in terms of reactive architectures, in terms of reactive web architectures in particular. So in the next section, we're going to talk about Project Reactor and its relationship to Spring.
Perfect. Thanks, Juergen, so much. Any thoughts from the Spring team, or would you like to, there's a question or two from the audience? Okay. First question up is the one I think we all expect. What's the time frame for Spring Boot to be integrated with Spring 5, Framework 5?
It is, so in all brevity, Spring Boot, of course, is a key entry point to all of this. Spring Boot to the Dough is in its late milestone phase now. It's going to have a first release candidate soon, and we're aiming for general availability this year still, so in December. It's not far away, and if you want to give it a try, take the latest milestone 5, the upcoming milestone 6. You're going to have a very fine experience trying Spring Framework 5 features through a Spring Boot 2 milestone, even at this point.
Yeah, I think Spring Boot 2.0 M4, milestone 4, is up on the initializer website right now, if memory serves. So I tried it out at Java 1 for a Reactive Lab, and it worked just great. Next question is WebFlux based on RxJS version 1?
We're going to get to that later in the webinar, right? But we are based on Project Reactor. I can give a preview on that part. So for that, at the heart of our stack, of our internal processing stack, is Project Reactor itself and the reactive streams abstraction. We have first-class integration with both RxJava 1 and RxJava 2. If you choose to use it in your signatures, we know what to do with it and how to adapt it to our internal processing stack. But the most streamlined experience, the most streamlined processing architecture you can get out of using Project Reactor directly, as you're going to see in just a few minutes.
Yep. Great. Thanks, Juergen. All right, we're just about out of time for this segment, so there's a few other questions coming in, but yeah, if you're curious about what other Spring projects are doing reactive work, go down to the attachments and links section and look for the FAQ, and you'll see some detail about what other Spring ecosystem projects are looking to, are either delivering or planning to deliver already Spring reactive supports. Great. So thanks so much. Let's shift gears a teeny little bit over to, as you said, Juergen, Project Reactor. And we're lucky enough to be joined by Stephane Maldini. Stephane, would you like to talk a little bit about what we're doing with Project Reactor?
With pleasure. So I'm leading the Project Reactor initiative. If you've heard about that, it's a kind of library, a very small one. You can include in any kind of project. It's not necessarily tied to Spring, and we come to that in a second. It's a small, what we call nowadays a reactive library, and it's something we can perceive as an extension of the Java language itself. It adds two main types called Flux and Mono. And as you can see in the slide in the background, they are just syntactic constructions you can use to chain actions on top of a source of data that might be pulled or pushed depending on what we call back pressure. So that's really important. This back pressure story comes from a specification named Reactive Streams, and we worked on that a few years ago with a lot of companies, mainly to quote a few of them, Lightband, Netflix, Oracle now has included Reactive Stream specification into Java 9, just released. Unfortunately, they are not aligned in terms of interface because the release of the specification happened before the release of Java 9, so we have an external library specification called Reactive Streams jar, and now we have that in the flow package inside the Java 9 JDK. So we implement Reactive Streams. Of course, we also have adapters to directly included into a Reactor for the Java 9 interfaces as well, if you're lucky enough to start playing with the Java 9 interfaces too. And we provide this transformation and programming experience directly to our user to work on top of any kind of sources of data. It can be list, can be your own source of data, can be something you want to push at a regular interval, can be timely based. And the important point is we try to request the data as the consumer can request it. So that's really the back pressure. Consumer might take some time to consume data. And you don't want to push data if the consumer cannot consume this data, because what happens? Well, that's the same thing that happens when you use, for instance, an executor. An executor in classic Java terms is, a service. You will submit tasks to it, and no information so far will tell you how much task can you still push. So what happens is usually you push tasks to this executor, and they accumulate because the work itself might be slow, and that's also mainly a reason you want to do asynchronous work. You have a difference of consuming and producing rate, but without the information, the back pressure information presented by the specification, the request or demand, you don't know when to stop. And that's really what we implement under the hood. Reactive Streams offers no API. It only offers a contract mainly implemented by libraries. So we have Project Reactor, now Reactor 3.1, but we also have RxJava 2, and we also have Aka Streams. These libraries implement directly operation, and so you can work on top of reactive streams. And then you have provider of data like Mongo or Lettuce, which is a Redis driver, which are source of data, and they would implement a specification so we can consume and operate on it using Project Reactor. So you might notice that the Reactor project itself is, in terms of syntax, quite close of RxJava, and it's not really a coincidence. We designed the Reactor project, the 3.0 version, with the RxJava lead, David Carnock, and we think that the Rx syntax is kind of an industrial standard nowadays. I think a lot of libraries come close to that. It's also very close to the streams, the stream experience in terms of Java 8 as well. So people familiar with stream will be familiar also quite quickly with the Reactor syntax. As I said, we come with two types. So Flux is really for a sequence of n elements, very similar to stream. And what is similar to completable feature is more what we call mono, something that might be 0 or 1, and that's it. So that's also a kind of specificity we have in the Project Reactor. We only try to work with back pressure types, so things that implement the reactive stream contract, and also a minimum number of types in terms of cardinality. So you see Flux for n, and 0 or 1 is mono. That's different, for instance, from RxJava 2, which implements both non-back pressure type and back pressure type. For instance, observable is a non-back pressure type, and flowable, new to RxJava 2, is a back pressure type and implements reactive streams. They also have more flavor to the cardinality, like maybe is for 0 or 1, single is for 1 exactly, and completable is for 0 exactly. And that comes back, the difference here is the simplicity we try to bring with Reactor and the focus we try to bring with Reactor 3 is really the reason why we close also from the Spring Framework project. Spring Framework and Project Reactor came to discuss a couple of years ago when we started to work on Spring 5, and we said, what do we need really and exactly as very focused API to make all of this reactive stuff work end-to-end and operate in a friendly fashion, I'd say, at least something we start being used to, like RxJava or Stream. And that's why we really focus on these two types. The cardinality we defined with Flux and Mono were just enough for us. We worked with the Spring Data team as well, with the web team as well, to see what kind of response we will be more or less used to work with 99% of the cases. And this relationship brought more than these two types. In fact, over time, we started deciding new operation we wanted to include in Reactor, which are not necessarily included in RxJava, for instance, or other libraries. And specifically, now we have new use cases, new ways to pass information also between functional steps in a reactive flow, and that's the context feature, which is new to 3.1, for instance, that comes exactly from needs like Spring Security. And, if you're familiar with Spring Security, you know the annotation like @secured. And you can still use that nowadays with Spring Framework 5 and Reactor 3.1 to secure flows that are typed with Flux or Mono, not a user, for instance, or a POJO, as you used to do with Spring Framework 4, for instance, and Spring Security. And that's important, because they use this new feature. They ask us to provide a way to pass contextual information. In this reactive flow, you cannot use thread local. I'm pretty sure we will have questions about that in the end. So we have to come with this kind of alternative. We have to be facing enterprise needs, basically, that is building most of the requirements we have around Spring frameworks. We have concrete use cases, and directly Spring framework is the best feedback we could have as a reactive library to add these features, basically. And so we kept this library, Project Reactor, as a separate module from Spring, because you can use that without Spring, but also because the domain we try to solve is really difficult. As I said, you cannot use reactive stream directly. You have to use an implementation, and all of these implementations are isolated in scope. They only do what they try to do when they build operations like us. They do this operation on top of reactive stream, and that's it. This scope is already complicated enough, and we have built enough experience on top of that to provide you guidance, etc. To assimilate this, consume this library separately is already a certain challenge. And I think that's also a reason Rossen is going to explain later why we also still provide a flavor of reactive and non-reactive efforts in the latest Spring versions. So if you have any questions,
yeah, absolutely, yep.
Yeah, if you have any questions, don't hesitate.
There's a quick question from the audience in the few seconds we have remaining. Curious if there's any reactive data stores being supported aside from the NoSQLs. And I think the short answer is that, not yet, but I saw Oracle announcing something about a reactive JDBC driver, but I think it's just NoSQLs to start, right?
There is one driver, PostgreSQL. They have a driver, an asynchronous driver, but that's the only one I know, as far as I know. But yeah, you're right. We have seen at Java 1 an announcement around JDBC 2 and possibly a reactive stream support. So something to look for.
Well, great. Thank you very much, Stephane. Appreciate it. And if we didn't get to your question, we'll get to it in the attachment. So please do ask. Rossen, let's talk a little bit about the servlet model and non-blocking code versus synchronous.
Sure, yeah. So far we have talked about the reactive support in the Spring framework. We've talked about the Reactor project. But what's also important to talk about a little bit is what we actually have in Spring 5, what we've done with all of this, and a little bit about why we've done it. And I guess a good place to start from is I think pretty much all of us are very familiar with the benefits of asynchronous calls and asynchronous code. For anybody who's done network calls over HTTP, to introduce, for example, a sequence of calls to introduce some sort of asynchronous client there, clearly there's a lot of benefit that you can achieve by taking off that latency and performing multiple calls at the same time. What is actually a lot less obvious to us Java developers is that there are multiple ways to achieve concurrency. Since from a very long time since we began with servlet container and the servlet API, we pretty much have it in our mind that to be asynchronous, to be concurrent, takes a lot of threads. This is a very common misconception that I come across, and Also something that I've had to work with myself to get through multiple layers of kind of explaining it to myself and getting to a new level of clarity. But basically, if you think about a synchronous API that needs to block, you can use a thread and you can make that asynchronous. And if you have a lot of these concurrently, obviously, if you have a lot of these blocking operations, you need extra threads in order to absorb that latency and to perform things concurrently. But actually, there is another way to do this. It's not the only way. So, for example, if this is something that servers have been doing for a long time. If you look at, for example, the way Jetty or Tomcat work internally, or other servers, at the lowest level, the way that they handle a very large number of connections is by being not only asynchronous, but also being asynchronous and non-blocking. And when you are non-blocking, that means that you are using a very small number of threads. And if you think about the example of Node.js, they only use a single thread in order to process on the server side many concurrent connections, which I guess in itself proves the point that you don't need a lot of threads in order to have concurrency. And this is the kind of effect that we're looking for here as well at the application level, is to gain the benefits of asynchronous and non-blocking execution model with a very small number of threads, which then makes the application more resilient, more scalable, and using less resources. That's the outcome. There's a lot that I could explain here, but in the interest of time, I will basically move on and leave that as an exercise to kind of go out and take a look more on this topic. But basically what we wanted to do is to take advantage of this non-blocking execution model for web applications. And of course, Spring MVC, the original web framework in the Spring framework, is built on the servlet API. And when you're using the servlet input and output stream, which is basically the way you read from the request body and write to the response body, you're effectively using blocking operations. And to change that requires very deep change. Basically, you have to start from the bottom up, and you have to build essentially a new stack. In other words, it's easier to become asynchronous, but it's much harder to become asynchronous and non-blocking. Now, the Servlet 3.1 API does have a non-blocking I/O option. But if you use it, it's sort of a binary fork in the path. You are either using the synchronous version or the synchronous parts of the Servlet API or not, or you're non-blocking. So you can see here on the left and the right, we have two different stacks in Spring 5. On the left is the Servlet stack, which is a traditional Servlet container Servlet API Spring MVC. And then on the right, we have Servlet 3.1, but also other runtimes like Netty and Undertow, which we're using through native APIs. And we've built a sort of an HTTP I/O layer on top of that with the help of the Reactor project, and that's where Reactor comes in, giving us that reactive streams, back pressure applied against the request body and the response body, allowing us to translate that into the application as back pressure. If you're reading from a data store or writing to a data store, you can pass through all of that. And we have a Spring WebFlux framework built on top of that, which has an annotation-based programming model. So we support the exact same annotations as Spring MVC does. So you can write the same kinds of annotated controllers, but on a completely reactive foundation. And we do have some reactive support on the Spring MVC side, so I'll talk about that in a little bit. But Spring WebFlux actually contains annotation and also a functional programming model that Irene is going to talk about, and why we did that and what was the idea behind it. But this, in a nutshell, is what we have in Spring 5. You have a choice between two different stacks, and there are some significant differences also in the way you program if you go completely reactive as well. So with that, I'll take a pause here for any questions, if we have any.
Absolutely. Yeah, I think there's a couple different ones. I think the one that we all expected was, so I'm really glad to see it. Rossen, is it possible to use HTTP2 with Spring Framework 5 out of the box?
You can use HTTP2. Tomcat is Tomcat supports based on Servlet 4.0. Both Tomcat and Jetty support HTTP2. Primarily, this is about protocol level changes, so huge changes at the server level, but really not so much change at the API level.
Awesome. Okay, thanks. I think this is from an earlier. I think this is from Stephane's section, so I'll pass on that one. But or if it's okay, maybe we can take a half step back. There was a question about why is an exception a terminal event in a Flux? Why couldn't it get handled by the error handler and proceed with the next event? I think that's more directed to Stephane.
You can handle it. There are ways to handle exceptions. The point is that if it remains unhandled, it becomes terminal.
Got it. Okay. More general question, and just jump in, whoever wants to answer this one. I don't think it's directed to anyone in particular, but with reactive programming in Java 9, what's your take? Will we be able to more easily implement as efficient components and modules and services as you can with, say, Go?
Yes. If I was to give a simple answer, is it easier to implement more efficient components? I mean, this is a very broadly phrased question, obviously.
Yeah.
And I'm jokingly answering with a single answer, yes, there. But the fact is that there is a very substantial change here. I mean, this is a revolutionary change that goes all the way to the server. As you can see here, this is the kind of change that happens once in, 20 years since the Servlet API was first created. And the network layer or at the server layer, there's been a ton of changes over all these years. There's been a ton of evolution and improvements in efficiency, but the Servlet API in between has by and large remained synchronous, and that's what most applications use. So here we're talking about completely changing the execution model from one that uses a ton of threads to scale to one that's using a very fixed small number of threads. That's a huge change, and yes, that is going to have a big difference in terms of performance characteristics, amount of memory, number of threads.
Does Tomcat support the reactive stack versus Undertow, for example?
Oh, it's a good question. One that we often see. How is it that Tomcat and Jetty can be on both sides in each stack? Tomcat itself and Jetty and Servlet 3.1 containers are supported in the reactive stack, and this is something unique that we do in the async non-blocking space. I think if you look at other frameworks out there, they tend to focus on Netty primarily. But the fact is that both Tomcat and Jetty support the Servlet 3.1 non-blocking I/O, which means that there is a way that we can translate reactive streams back pressure into the non-blocking APIs of those servers, in this case Servlet 3.1, which means that we can support Tomcat and Jetty in the reactive stack. The main difference between left and right is that on the right you're actually not in any way seeing the Servlet API. It's just a server adapter at the lowest level. And the API you have above that is actually a reactive streams and Reactor-based API for consuming the request body and the response body.
Okay, Rossen, I'm going to intentionally run a little overtime in your here because I think there's one or two more very critical questions that we should probably answer. Someone asks, isn't it possible for someone to combine Spring MVC and Spring WebFlux in a single application for any reason?
WebFlux provides both client and server support, so we actually fully anticipate the scenario of combining Spring MVC with the WebFlux web client, especially in a microservice architecture. It is very, very a good combination to do that. And I'll talk in a little bit about what we've done in Spring MVC actually for reactive support.
Awesome. Thank you so much. And I think there was one more really critical one. Hold on 1 second. Yeah. Okay. Oh.
How about this one here? How is reactive different from
it.
returning a deferred result in a REST controller and calling external service using async REST template? Well, except for the lack of back pressure. Yes, that is one of the major differences. There's a lack of back pressure there. Also, with Reactor and reactive programming, when you use Flux or Mono, you're essentially declaring. It's a declarative API for what is going to happen. Just like with the Java 8 Stream API, when you declare operations, nothing happens until you actually are at the end of that, or in the case of reactive streams, until you subscribe. So that's one big difference. You're not triggering things immediately. You're just declaring your logic. But other than that, I mean, in Spring MVC, we support now return types. So internally, we can translate a reactive type to a deferred result by subscribing and triggering that. But again, we'll come back to that.
Okay, great. I think we should move on for the moment. There's a lot of great questions. Wow, this is fantastic. So let's you hinted at this a couple times already, Rossen. Let's maybe transition a little bit and hear from Arjen about the functional programming model. Arjen, would you talk to us a little bit about what's going on in Spring Framework 5?
Sure. Hi. Yeah. Yes, it's already mentioned by both Juergen and Rossen that we do have a new functional web framework that was introduced as part of Spring Web 5.0. You might wonder, why did we do that, right? Why did we add yet another web framework? Well, first of all, it's not the first time we do it, right? We had, for those of you who've used Spring for a bit longer, you might remember that we actually had a inheritance-based framework back in the day, where you would extend from an abstract controller or a simple form controller, etc. And then we introduced the annotation-based version, and eventually the inheritance-based version went away. And now we're doing it again. Basically, now we are introducing a functional-based framework. And we basically had a couple of design goals or inspirations when we started this. One thing is that Spring 5 was the first API that we had, first release that we had where we had a baseline requirement for Java 8. So we could actually build an API that was meant to be consumed or meant to be used through Java 8 Lambdas. That gave us a lot of opportunities, obviously. In Java 8, there are also two new APIs in the form of Java util function and Java util stream, which gave us some inspiration, basically how to approach building an API using these new facilities. Overall, our goal was to make it feel a little bit less like a framework and more like a library where you pick the exact components that we offer and build basically your own routing and handling mechanisms. We'll get to that in a minute. That also means that it's a bit more explicit, right? This was also very much a design goal through our internal consulting Pivotal Labs. We basically heard that some people prefer to have a bit more explicit model than the annotation-based model. Annotations are perfect for some use cases, right? It really solves a lot of use cases. Obviously, a lot of Spring is built on annotations, but if you are coming from other fields, then they might feel a little bit magical, right? One thing that's for sure is that it's very hard to debug an annotation-based web application, because for the simple reason that you cannot really put a breakpoint inside of an annotation. You can only put the breakpoint inside of the code that actually reads from or handles the annotation. And in order to do that, you have to know a little bit more about the internals of Spring. Certainly possible to to debug that and even extend on the annotations that we support and introduce new ones or customize the behavior of existing ones. But the fact remains that you do have to know a certain thing about the internals of Spring in order to do that. So basically, all these goals, we ended up with like I said, a functional programming model. And if you look in the slides, you can actually, I hope it's visible, you can actually see that we have an example there of in this case, a person handler, which would be take the role of a controller in Spring MVC. You can see that it just needs a person repository there in order to work, which just gets assigned through a constructor. Then we have a couple of what we call handler functions or handler methods in this case, because they're on a class. We can start with the last one, list people. Given the particular server request, we use the repository to find a flux of people. Flux is a type that gets that's coming from Reactor. It basically means that's a stream of 0 or more elements, right? As opposed to mono, which is also used above, which represents either no or a single element. So here we know that we get a stream of persons, we call that people, and then we return basically a server response where we say we want to have the OK status code 200, this particular content type JSON, and we want the body to consist of the flux of people. One thing that's interesting here, and people always asking me this, why do we need to list the person type there, right? Why do we need to list people, person.class? Well, this is one of the interesting side effects of actually being reactive, that this is not some simple list, right? The flux is not a list that you can just inspect and see what kind of elements are in the list. No, this is actually a stream, and the moment that server response code line gets executed, we don't actually know yet what kind of types are coming. I mean, we can expect it, and if Java had a bit more features in terms of type erasure, right? If we wouldn't have type erasure, I guess, then we could inspect the type, but now we have no option but to require that you list the person class explicitly, as we do here, for simple reason that we need to prepare basically the components that are responsible for rendering this as JSON. Going up one method to the create person method. Once again, you can also see that it takes a server request and returns a mono response, right? So we have effectively a delayed response, allowing you to execute asynchronous operations, obviously. We do pretty much the same there, right? We actually create a person here. So we take stuff from the response in this case, from the request in this case. So we convert the request into mono. We know that it's a single person in that stream. So we convert that to probably JSON in this case. And then we save it in the repository. I don't have that on the slide. It's available elsewhere. I'll give you a link later. But basically, the save person method on the repository returns a mono of a void, so basically a completion signal. And what we do in the create person method is that we use that completion signal in order to send our response. So effectively, this method will send OK whenever the save person method has completed, right? Whenever the person has been saved in the repository. The final method we have on there is a get person that's a bit more involved. So let's go through that as well. You can once again see that it's the same signature, and so given a server request, return a mono of a server response. That is, as you might guess by this time, the signature of a so-called handler function. And handler functions take the responsibility of a controller method in typical Spring MVC, right? The annotation-based MVC. So what we do here is we take a path variable, namely ID. We turn that into an integer, and then we actually prepare something up front. We say, well, I'm going to build a not found response up front, and then I'm going to query the person repository. If it has a certain person ID, it will return it as a person mono. and I'll return that. I'll use that person mono in order to give me a proper response. What actually is happening here is that if it contains a person, we're going to return an OK content type with the person as the body, right? If it doesn't contain, that's where the switch is empty. Switch if empty comes in. If the body mono, the person mono doesn't contain a person, then we effectively return a not found. So that's what's going on right here. Then below that, we have actually the code that uses this, or that wraps this up. So far we've only dealt with we've only written code that handles the request and creates a response. We haven't actually done any routing to that code. And then once again, drawing the parallel in Spring MVC, you would do that with a request mapping annotation, right? That's how you point Spring MVC towards the method that you want to invoke when it gets called. Here we do that with a so-called router function. And you can see below that we create a dummy repository, we create a person handler, and then we create a router function, which is basically what's returned from here. We nest to a particular path, which basically means that we're going to include a couple of routes, all using the same prefix, in this case person. Then we do another nest. We group a couple of methods that actually have the same accept header, that require the same accept header, in this case JSON. And then we have two routes basically. We route if the request has a get for a particular ID, then we route to handler person, handler get person, right? You can see the Java 8 method references being used there. And we also add another route where we say if the method is just get, combined of course with the nested prefixes that we declare above. So if the method is get and the path is person and the accept header contains JSON, then we go to list people. Finally, we have one more. If we route, if it's a post to basically /person and the post contains data with an application JSON data type, we invoke handler create person. You can see that this gives a nice little DSL, but the important thing to note here is that these are all functions, and therefore these are all very much customizable. That was really what we're trying to achieve here, is to be very customizable in terms of how you route, right? You can do that any way you want to, and also what kind of predicates you would use when you route. So in this case, we're using the standard one, path, accept, get, method, etc. But you can also write your own, right? That's very important. So if we, I don't think I have a lot of time left. If you also want to go through some questions, I do want to go to the next slide, please, Peter.
Yep, you got it. We're almost out of time, but we can run a little over.
Sorry?
We can run a little bit over, but we're almost out of time. Go ahead.
Right. One thing that's very interesting, and that Juergen might talk a little bit about in a few minutes, is that he already did so, I guess, in the introduction, that Spring 5 contains a lot of Kotlin specific code, right? We have a lot of Kotlin support in Spring 5. And I think that all pretty much started with the DSL that was written by Sébastien Deleuze, and I think it was also contributed. That basically creates a Kotlin wrapper around the slide that you saw previously. So the previous slide was Java, and the Kotlin, as you can see, is probably a lot nicer to read in this respect. I think it's pretty clear what's going on here. It's a bit, basically we create a router, we say if the accept header contains text HTML, then, and the header is get to / then render the OK with a particular index. If it contains SSE, then we render the other page, etc., etc. Among the links, there are now, I see that there are 106 links, so it might take a while for you to find it, but there is one link that contains a link to all the Kotlin reference documentation that we have in Spring 5. One thing I would like to say before we move on to questions is that this is a brand new framework. It has a lot of features, right? The functional web framework. It has a lot of features, so much so that I had a 1-hour webinar about this some months ago. And also among the attachments and links, you will find a link to that particular webinar with much more details than I can provide in these short 10 minutes now. So,
yep.
I think we might have some time for questions.
Not much, unfortunately, but take a look through the question stack and see if you want to pick something out from the top. There's a couple, 1 or 2 about Kotlin. Most of the questions seem to be about other topics, but
okay.
How does exception handling work in the functional WebFlux programming model? Seems like a good one.
Well, that's the part where it means it's very explicit. So there are a couple of ways to deal with exceptions, right? But eventually, in a way, it's all basically down to the error handling that Reactor gives you, right? You have a lot of, if an exception occurs as part of your Flux or Mono, you'll be able to add exception handlers there. So as you saw by switch if empty statements earlier before, you could also have similar statements which do I think Sebastian, I'm not exactly sure of the method name, but you can switch basically to based on an error. If a particular error class occurs, then go to this page. You can also register global error handlers as well. That's all possible as well, but the fact of the matter is that this API is quite explicit. There's very little going on in a automatic fashion. What you see is what you get, I guess.
Okay, great. Thanks, Arjen. There was a question about the annotation-based model as well. Hang on just a moment. I'm trying to find it.
Well, here's an answer. Would we have annotation-based reactive endpoints?
There it is. Yep, that's it.
Yeah.
That's exactly right.
Well,
yep.
we do, right? I mean, that's Rossen is going to talk about. I think he'll talk about that in a short while. Talking about mostly MVC, but also maybe a little bit about the annotation-based MVC that we have in WebFlux. You can absolutely use the same annotation-based model that you know and love from Spring MVC in a reactive controller. The only difference that you make is that, really simplified, the only difference is that you would return a flux or publisher of something, right? Rather than a list or a set or a collection of them. So you were returning from your controller, you're returning streams of elements, reactive streams of elements rather than collections. This is just an alternative API, and the thing to remember is that, well, we try to get all this code on one slide, which doesn't really facilitate readability. However, this is code, and you can plug that up and assign each routing function to a particular variable, give that a comprehensive name, and try to combine that in that fashion, right? That's a lot more. There's a lot more possible than we can show on one single slide. I guess that's what I'm saying.
No doubt. No doubt.
And,
all right.
and actually, I do want to bring up the point that one of the reasons why we have the functional example here is because it's not something that most would be familiar with or have seen. But in fact, we do have the annotation-based controller programming model support as well on the WebFlux side. And I want to talk a little bit about that actually and about Spring MVC. What does all this mean for Spring MVC? So obviously this is not a deep dive informational presentation talk. It's more about discussing the features from a higher level perspective. But what I want to talk about a little bit is since most applications today would be obviously Spring MVC based and servlet based, and that's the background that most of us are coming from. So what does this all mean for Spring MVC? Well, first of all, I want to point out that Spring MVC also has reactive features that we've introduced, and we sort of changed our minds along the way towards 5.0. When we first started out with the reactive stack support, we took a very conscious decision, and this is in Jira, actually, a long discussion, around whether we should support Flux, Mono, RxJava observable on the Spring MVC side or not, because this is something that was actually being done in Spring Cloud. And we took a conscious decision initially to keep things separate. We thought this is the best way because not to get things confused and mixed with reactive types supported only on the reactive side in Spring WebFlux. As we moved closer to 5.0 GA, it sort of became much more natural as we understood the reactive support better, that supporting reactive types on the return value side for Spring MVC is a very natural thing to do, and so we did that. And to come from a use case-based perspective, basically, we pretty much expect situations where an existing Spring MVC application or a new Spring MVC application will need to make HTTP calls to other services, scatter, gather style. And when you start doing that sort of thing, it's actually extremely helpful to use the reactive web client that we have in the Spring WebFlux module. And you see an example here on the slide. What's interesting, actually, is that this method works just as well in Spring MVC and Spring WebFlux. You can simply change the dependency between one and the other. Especially if you're playing with the Spring Boot starter, the WebFlux and the Web Starter is literally just a small tweak, one-line tweak on the POM. So what you see here is basically a call through the reactive web client. You can see the functional API that we have. It's quite a bit different from the REST template approach, for example. We're making a call to a particular URL /cars. Then we are decoding that stream, and we're taking the first 5 car objects, elements, and then we're using flat map because we're making a nested call. For each one of those, we're going to make another HTTP post to make a booking, and then we're taking the result of that. Next actually means give me the first one, give me the next element. So you can see here how, first of all, a couple of things. First of all, the power of composition API that Reactor provides. We can use these operators to compose our asynchronous logic to declare it, and nothing gets triggered, right? We're not firing these requests immediately. We're simply declaring what we're going to do, and that makes it possible for Reactor to do this in the most in the right order, so we can make these calls in parallel. Well, based on the declarations here. And then, so obviously this is something that would be very useful in a Spring MVC application, and we wanted to support that to make sure we had already seen examples of that taking place in various applications. So in Spring 5, Spring MVC supports reactive types to be returned from the controller. If you're streaming, we actually support back pressure on that as well. But there are, of course, differences. For example, when it's time to actually write to the response, it's still a blocking call. Another thing that you can't do in Spring MVC is you cannot deal with the reactive type for the request body. That's not something that's easy for us to introduce based on the blocking servlet API. So you can clearly see that there are advantages here. And once again, I want to point out that this is a unique sort of position that we have. There are other solutions out there for asynchronous and non-blocking programming models. But what you'll find in the Spring Framework 5 release is actually a servlet stack and a WebFlux, a reactive stack side by side. Not only offering you alternatives, but you also have choices on the servlet stack, which is where most applications are today, to do reactive things, to use reactive libraries, and to have Spring MVC support you as far as it's possible to take it on that side. I would like to also leave a little bit of time for maybe Juergen, if you'd like to add a few words about Spring MVC and Spring WebFlux and sort of the way forward. I think one of the common questions that people wonder about is what does this mean for Spring MVC, that we have Spring WebFlux? Does it mean that we're all going to start using WebFlux in the future?
Yeah, absolutely. That's a key question to ask. But in the end, the answer has many sides to it. So just to be clear, an existing Spring MVC-based application that you're running on a servlet stack can, of course, keep working just as you have it on a Spring 5-based application, right? So if you're upgrading an existing Spring MVC application to Spring 5, there's a very natural upgrade path because Spring MVC, as you know it, as you love it, is still there with all its servlet-based contracts, with the servlet API shining through, even the ability to declare an HTTP servlet request in your request mapping handler methods. So Spring MVC is still there. There's no disruption on that upgrade path. So if you're considering that, please consider a straightforward upgrade to Spring 5 on that basis. Now, if you're developing a new application or a new service in the microservice architecture where you know that there's a lot of resource contention, where you'd really like to optimize the processing of larger streams, longer streams, of very unreliable network connections between the systems. There may be many reasons why you're considering this. Then you could choose to start with WebFlux, with the reactive stack for that particular service, for that particular application. But if you like, of course, you may keep using the annotation-based model. The annotation-based request mapping model, if you're deploying such controllers to the WebFlux stack, they're running on the reactive stack. They're running on the WebFlux engine, on React underneath. So you really make a conscious decision deploying to the reactive stack versus the servlet stack. An annotation-based controller may look very similar. In some cases, it may even behave very similarly. But you still deploy it to the reactive stack or the servlet stack. There's no transparency at that level. There's no total transparency, at least. You're not supposed to abstract this away. You make a very conscious decision for one stack over the other. You're optimizing your arrangement for one stack or the other. And there are just limitations in terms of what you can do and cannot do in one stack versus the other. For example, to hold on to thread local-based information, to thread local-based transactions, thread-bound transactions, the servlet stack is your natural friend. And you're probably best off if you just upgrade on that basis. Whereas if you have a reactive driver available from your data store, or for a new system, a new application, a new service that you're developing, if you're able to choose a data store with a reactive driver, then by all means, take that reactive power that the reactive driver gives you and try to expose it up at the level of your web endpoints. This is exactly what WebFlux enables you to do. It's an enabler for top to bottom and back up reactive processing from the HTTP endpoint down to the data store and back up. We're providing everything you need to make a smooth, very efficient runtime stack out of that. So it's very much driven by what you can do from the data store level, right? If you're using blocking JDBC, if you're using JPA, any other kind of blocking variant with thread-bound transactions in particular, you're probably better off with the servlet stack. There are ways of going about this. You may use a worker thread pool there. There's always a way out, but to get the best possible experience out of this, by all means, your starting point is probably the servlet stack. Whereas for the reactive driver, as mentioned, it's the starting point for a reactive data store driver is, of course, the reactive stack, if you're free to choose. So this is what we are providing in Spring Framework 5. Two web frameworks, Spring Web MVC versus Spring WebFlux, one on the servlet stack, one on the reactive stack. there's a lot of effort going into alignment here. So they have this characteristic feel of Spring MVC, of annotated handler methods in Spring in general, because the same model applies to message endpoint methods and WebSocket stomp endpoint methods. And the Spring MVC request mapping follows the same model, right? So you can have a very similar experience with the annotation-based endpoints. On WebFlux, if you choose to do so, the functional model is an additional option, a bit more directly integrated with the underlying stack, and more, you might argue, a more natural way of expressing yourself in a highly functionally developed application. So it's up to your preferences. Two variants of consuming the WebFlux stack. In parallel, there's of course Spring MVC as you've always used it on the servlet stack, and as Rossen highlighted, there are ways to cross the boundaries, to mix and match a little. You can use the reactive web client in the servlet stack. The servlet stack does the best possible job if you return a reactive stream to it, like a flux or a mono, maybe coming out, not necessarily, but maybe coming out of the reactive web client. The servlet stack knows what to do with it. So we're trying the best we can to handle what you're giving to us at runtime in both variants of the stack. But keep in mind, this is a rather subtle arrangement, right? So in order to understand the nuances of decision making here, you really need to familiarize yourselves with the benefits of a servlet-based stack versus the benefits of a reactive stack. Spring is then in a great position for you already to give you everything you need, depending on the decision that you make. So maybe also making it very clear on the way forward, we are of course not taking any of those options away either. Both Spring Web MVC and Spring WebFlux are first-class options in Spring Framework 5. Both of them are very actively developed. You've already, if you're looking at Spring MVC in the 5.0 release, you will notice quite a lot of enhancements compared to the Generation 4. Some of them more internal maybe, but nevertheless very actively developed. We will keep actively developing both stacks, of course, in the Spring Framework 5.x line, 5.1 and 5.2. So you're by no means on a kind of a maintenance version of Spring MVC here. Both are actively developed first-class stack options for modern-day web applications, depending on which fits your requirements best. We're doing the best we can to also take it forward with you, with all the applications and the requirements out there into the next few years. So we made a very explicit decision here to provide both options, to be a little more agnostic to your needs, to what your needs demands from a web processing architecture. Spring always had a bit of a toolbox mentality. I guess this keeps shining through here. Whereas, of course, if you take Spring Boot as a starting point, you already at the very beginning choose the Spring Boot WebFlux starter or the traditional WebMVC starter. So Spring Boot will guide you a little along the decision-making process. The tutorials will guide you a little and kind of educate you a little in terms of what you can do and how you can mix and match possibly. But in the end, it's you making the decisions, Spring providing the tools and the frameworks to support your decisions in your particular application architecture. All right. I haven't actually looked at the questions in the past few minutes. Are there any interesting ones?
Scary place.
I'll answer. I'll pick up a couple of easy ones here that I see. One of them is, I'm confused now. If Spring MVC can support reactive programming, returning mono, for example, then what is the advantage of using Spring WebFlux as opposed to Spring MVC? So in a nutshell, we do support reactive types as return values in Spring MVC, and we support even back pressure there. But when we actually have to make the write for that value, we still have to use blocking I/O. So that's one essential difference. We actually automatically switch threads to ensure that whatever is sending an event on the mono, which is probably making non-blocking execution model assumptions. So we use a separate thread to make that write, because that write is blocking and it needs an extra thread. The other difference is that you cannot process non-blocking on the input side. You cannot process a request body in Spring MVC with mono. Or Flux. Another one here was about testing support for the functional endpoints, but also for annotated controllers. Is there an equivalent of mock MVC? Yes, we actually have something that's quite comparable and can do even more. It's called the web test client. The web test client is an actual client. It uses the reactive web client, so you can use it both for end-to-end integration tests against the running server, or you can also do the same kinds of things that mock MVC supports, which is to test without a running server. So take a look at that.
Cool. Yeah, I saw the testing one come up a couple times. Thanks for hitting that.
Mm-hmm.
That's great. And then can reactive? I mean, I think you kind of addressed this, Rossen, but can reactive endpoints communicate with the non-reactive ones? I think you just kind of covered that a little bit.
Yes. Yeah. So let me be more clear. In fact, when we use a Flux or mono to return from the controller, this is no different than, say, using deferred result or similar asynchronous types that in terms of what the client sees. From a client perspective, a client still sees just the HTTP requests and responses with serialized data, including JSON and other formats. But as far as what you use on the server side, the Flux and mono completely has to do entirely with the way you handle requests. It does not affect the client.
Got it. Okay, great. One other question, and we're going to wrap up soon. We're going to take a couple more, and then we're probably going to have to close it up. One more, just talking about getting started guides. Like, what are we going to be helping people? What are we going to be producing in terms of documentation and guides and tutorials and that sort of thing? To help our users start to get their head around this. And, I just wanted to highlight, Rossen, I just wanted to give you a chance to highlight the documentation work that you very recently published that's linked to from the right up front on the homepage. You want to talk a little bit about sort of what's in there to help people figure this stuff out?
Sure. And over the last year and even two, we've had plenty of talks. So if you go to the usual places like Devox or InfoQ, you will find, and we have some links actually to the InfoQ. There's a reactive programming tab. You will find a lot of talks on Reactor and Spring 5 in more detail. There are also workshops. There's a Devox University session, a 3-hour session by Brian Kozel and Sebastian Toulouse. Also team members who, there's hands-on code associated with that. So there's a lot of these kinds of resources you'll find already. The reference documentation is somewhat still being completed, but it's more complete than not. So there's a ton of useful documentation there. And more will appear probably by 501, so on pretty short order. But we do have some substantial portions of the reference documentation already in place. We're working on tutorials and getting started guides. And if you really look around and just look at the links provided here, you will find that there's a wealth of examples out there and places to get started and run some code.
Thanks so much. Okay, I think there's a ton of questions that we're not going to be able to get to today, folks. But just a couple quick things. Juergen, sorry, did you want something?
I'd like to summarize a few points I've seen in the questions.
Please,
so if you're
go
using,
ahead.
For example, an Oracle database and you use traditional access to it for JDBC or JTA, you have to use special solutions like a worker thread pool in the reactive stack. The more natural stack for you is certainly the servlet stack, which you can highly optimize on its own terms, right? But as initially mentioned, Oracle is working on a reactive JDBC model. I'm sure they're going to implement that in their Oracle database driver at some point. So once those drivers become available, those databases like the traditional Oracle setup might become a natural citizen in a reactive stack, but we're not quite there yet. In terms of, I've seen another question, just to clarify, Spring 5 is fully compatible with Java 9, both on the class path and on the module path with a well-defined set of module names. So we support the deployment of Spring 5-based applications on JDK 8 and JDK 9 as of this day in production setups, right? To the degree that the underlying JDKs are production capable, of course, we will also support the upcoming revisions of the JDK, the half-year releases that they announced recently. And the Spring Boot to the door release, I've mentioned that already. The question came up again, is targeting December this year. So it's not far away at all. If you'd like to get started with it, please do so now against the current milestones in Spring Boot to the door. There's Spring Framework 5 GA underneath those covers. Let us know. There's a lot of interesting lessons we can all learn together here still on the way to Spring Boot to the door final in December. So now is a great time to get engaged there.
One last one that I think is worth addressing quickly, and I've seen a number of questions along this theme. Thanks, Juergen. I think you dispensed with a lot of them right there. Is there interoperability with Spring Framework 4 microservices and some of the Spring Cloud projects? Does anyone want to take a quick whack at that, or is that sort of too open-ended for the last 4 minutes that we have available?
I'm not 100% sure if the question is about Spring 5 support in Spring Cloud projects or about... I guess it is kind of
I think we kind of have to frame it. Yeah, I think it's sort of open-ended, but...
Spring Cloud is going to support Spring 5-based, Spring Boot 2-based application setups, of course. So it's also already it's officially released train, right, in its milestone phase. In terms of the interoperability between Spring 4 and 5, if they're separate services, they interoperate through the HTTP networking stack, right, networking layer. So they are totally decoupled. You can, of course, mix and match as you choose, even between separate microservices here. Also, just to be clear, Spring Framework 4.3 is also actively maintained still. It's kind of in maintenance mode, but very actively maintained, very regular maintenance releases coming your way still. So we provide support for you on both paths, immediate upgrades to Spring 5, or also partial upgrades where some of your setups, some of your services are going to stay on Spring 4-based versions for the time being. But others, selectively, you may already upgrade to Spring 5. That's an absolutely feasible path for a larger system landscape that you may have.
All right, everyone. Thanks. We're about to finish up here, literally in less than 1 minute. So please click on the attachment tab and bookmark the resources that are there, as Rossen mentioned. Feel free to rate the webinar if you like, and we're going to be coming back with an upcoming series from Michael Plod in InnoQ in Germany on domain-driven design, which is going to be a 5-part webinar series. That's going to be pretty awesome. And then, please, the discount for Spring One platform in December in San Francisco expires very, very soon. So if you're looking to get your ticket, you should do so now before the discount expires in about a week. Thank you, everyone. We're really happy that you came, and look forward to watching the replay at the same URL you used to register. And congratulations to the Spring team on this release.
Thank you.
Thanks, everyone, for joining.
Thank you.